Hello and welcome back to Paleocast. My name is Dave Marshall and you're listening to episode 122, which is the second part of our look into the Dietary Ecology of Smilodon fatalis with Dr. Larisa DeSantis of Vanderbilt University. In the first part of this interview, episode 121, we set the stage for this discussion, learning about the different proxies that can be used to determine the diets of extinct vertebrates and how fossils are preserved at Rancho La Brea. In this second part, we'll be looking specifically at what Smilodon was eating, how important its saber teeth were, and how dietary niches were partitioned between the predators of the time. As a reminder, this was a listener-requested episode, so don't ever be afraid to message in with any suggestions. Which organisms, localities, events, or periods would you like to hear about? And as always, we've got images to accompany this episode on our website, and make sure you're following us across all our social media platforms. Likes, shares, comments, and donations all really help the show out, so please leave a little love if you enjoy this episode. So now that we've collected our data, can you actually tell what Smilodon was eating?
Yeah, so there's a lot of information we can get from drilling the teeth. And one of the things that we've learned from studying Smilodon at Rancho La Brea, but also looking at Smilodon more broadly at other locations, is that they really are these ambush hunters and are eating primarily forest-dwelling prey. So they are primarily eating things that are occupying their time in some sort of forested environment. And there's some sort of cover available to Smilodon to be able to sort of ambush its prey. And how we know this is we get these more negative delta 13C values, these more negative carbon isotope values than we do from things like dire wolves. Dire wolves, in contrast, are eating more open habitat prey, things from grasslands, things like bison or horses, whereas Smilodon is really concentrating on more of the forest-dwelling prey.
So would it have a dietary ecology closer to that of a modern tiger? Is that a good example?
Yes, tigers are a potentially good analogy in the sense that we think that they're eating mainly forested prey. That being said, tigers are solitary cats. Most cats are solitary, but Smilodon may not have been solitary. It may have actually hunted in groups. We don't know what those groups look like, but the reason why we think that they might be social is a few reasons. One is they occur in very high numbers. And so on average, if you look at the relative proportion of Smilodon or dire wolves compared to things that are typically more solitary, like cougars, there are far fewer cougars at La Brea than there are Smilodon or dire wolves, for example. There are far fewer giant short-faced bears or even American lions than there are Smilodon or dire wolves. And so this leads us to believe that Smilodon may have been social and may have congregated in larger groups, potentially even hunting in larger groups as well. What's really interesting about the tiger is that tigers are solitary when they hunt, and we actually think that the American lion might have behaved much like a tiger in being solitary, taking down prey kind of by itself, and also taking down prey in sort of more of a forested environment.
Is there any difference in dietary ecology between the specimens of Smilodon that we see at Rancho La Brea and elsewhere in the world? I think they go as far down as Brazil, is that right?
So there's some indication that Smilodon fatalis did make it into South America. There's also another Smilodon species named Smilodon Populator, which is very large Smilodon that also lived predominantly or actually entirely in South America. And then there's another species called Smilodon Gracilis. And this is one that occurred sort of earlier in time. And as the name implies, Gracilis, it was the more gracile or smaller saber-toothed cat. And these we find in locations in Florida and other places, across the U.S. But there's some really great specimens from Florida that we've been able to study. But essentially, there's only a handful of places that we can study Smilodon. And so from the localities where Smilodon has been isotopically analyzed, in pretty much all cases, we find that they concentrate or they primarily consume sort of woodland, forest dwelling kind of prey, and that all of the isotopic data is consistent with this sort of ambush hunting. So yeah, from studies of Smilodon Gracilis, fatalis, populator, kind of all in, throughout their distribution, there's only actually one sample that even shows kind of a mixed C3, C4 value. Everything is pretty much primarily consuming C3 resources, so kind of forested prey.
Okay, and you said before that we can see a lot of detail in the teeth as to how the diet, we take snapshots of what was happening in its dietary ecology as that enamel was laid down. Did it typically remain the same over time?
Yeah, so some previous work by Robert Faranek has looked at sort of serial samples along the entire canine in Smilodon. And there isn't a huge amount of variability. There is some variability, but largely it's sort of all within this kind of C3 realm that kind of, will wiggle back and forth a little bit, as you might expect. But there's not an incredible amount of variation. These animals aren't switching from eating forest prey at one moment to eating, open bison at the other. They're not kind of doing that kind of prey switching, we don't think.
So if you go on any sort of social media message board and Smilodon comes up, people are always discussing about how it hunted and killed its prey. What are some of the strategies employed by modern felids, and are any of those a good model for how Smilodon was hunting?
Smilodon potentially hunted very differently than modern cats in one regard, and that's because it had these elongated canines. Those elongated canines are prone to breaking. And so essentially Smilodon really has to be able to restrain its prey before it delivers that kill bite. So the benefit of having these large canines is that you're going to allow the prey to bleed out much quicker. And so that prey is going to die much faster than it would if you were sort of restraining it with other sort of less elongated teeth. That being said, those teeth, because they can break so easily, you have to really be able to restrain those prey. So it's sort of a balancing act between, restraining the prey, not breaking the teeth, but then being able to deliver that kill bite essentially, or the canine shear bite. How they hunted is still kind of a little bit of a mystery and discussed, but probably they hunted in groups and were probably social hunters. One thing that also is providing us with some really interesting evidence is that they were social, is that we see a large number of saber-toothed cats with injuries that survive with those injuries. So, for example, we know that these saber teeth are really important, and we know that canines in general in cats are very important. And the reason why we know they're so important is because, when you were, a kindergartner or a young child, you lost your teeth. And I don't know about you, but when I lost my teeth, I had about 8 teeth gone at the same time. And so if I tried to eat an apple, for example, I wouldn't be able to. I'd have to cut it up and, put it in the back of my molars and then kind of chew it up. And so it would cause real problems with eating particular types of food. In Smilodon, they actually have these little grooves kind of in the inside of their canine where that adult tooth is literally going to erupt at the same time when it has its baby tooth. And so it retains the baby tooth up until the point that that adult tooth erupts to a certain degree. And this means that these saber-toothed cats are not left without sabers. They have an ability to hunt, to acquire prey, and that's really important. Now, I also said that they're able to survive without these sabers. Now, how do we know that? there are specimens at Rancho La Brea where we can see that an animal has lost its saber, and that hole where the canine fit in has actually now filled in with bone. So if you lose a tooth, your bone will actually fill in where that kind of area was and where the root was. And so we see the bone is filled in. And what that means is that animal was alive for some period of time for that bone to be able to remodel and to fill in to where that root was on that specimen. And so it was able to live for some period of time without having that canine. And so that makes us sort of question how is this animal able to survive? Well, potentially there was some sort of social care. Potentially, lion or saber-toothed cats were able to kind of provide access to carcasses to those that were injured. And this is something we actually see in African lions today. There's amazing footage from National Geographic showing a lioness literally opening up this wildebeest carcass at the belly, holding it open so that this other female with a broken jaw can get access to the soft parts of the carcass. And so things like that might have been also possible with Smilodon. Lions do it today. They're social. They hunt social in social groups. Potentially Smilodon did something similar. And this isn't just sort of a pie in the sky sort of idea. This is coming from the fact that we see that many individuals with Smilodon have sustained injuries that they have been able to live with for some period of time. And even when those injuries are on their massive sabers or canines.
Have you ever found specimens with both sabers lost?
So that's a great question. I don't know. I know I have seen specimens at Rancho La Brea where there is evidence of one saber being lost and the bone having filled in to where that root was. There may be cases where both teeth had been lost, but I don't know that the bone had actually filled in those cases. It can also be challenging to know when the teeth were lost versus if they came out, right? So we know that, if it's been filled in with bone, we know that happened during the life of the animal. Whereas if there's just no canines present, an animal could have lost them, or they could have fallen out, in sort of the jumbling of the tar or asphaltum. And so really the indication that we need is being able to see the bone remodeling, the bone fill in those sort of roots during the life of that animal.
Did you hear Izzy then?
Yeah, was that your cat?
Yeah, she's having a hard time.
Ah,
Izzy, have you lost your canine? Don't worry, I'll feed you some soft food. You'll be fine. Right. Oh, jeez. What do you want? Do you need a drink? All right. Do you want to come up on the desk? Okay, you can be in the interview too.
very fitting.
Yeah, I know, right? Of course, she had to be a pest. She stays quiet for like the whole day. And as soon as I don't want her yelling her head off, it's either when I'm trying to do something or when I'm trying to sleep. She's just like, now's time to show everyone my beautiful voice.
Oh, yeah. Well, my dog has actually learned when I'm on Zoom that she can get my attention because, if she wants to be let out, she knows I'm not going to deal with her kind of whining while I'm on the computer. And so she'll pick that exact moment to then harass me to kind of let her out. So, yeah, they wise up pretty quick.
How prevalent is a broken tooth when you look at the whole population of all the specimens in Rancho La Brea? Like what percentage?
So that's an interesting question. It's fairly rare, but according to some studies by Blair Van Valkenburg and her colleagues, they noticed a pattern where a lot of the carnivores from Rancho La Brea had a higher incidence of broken teeth than African carnivores do today. And so this idea that, the carnivores from Rancho La Brea have, these broken teeth led to her kind of postulating that there was a tough times, that these animals were having to compete for similar prey, and that there was lots of competition, and that they were potentially having to, more fully consume carcasses. And that's why they were breaking their teeth. Now, we actually set out to test this idea with some of the dental microwear, and we actually found this not to be the case. So there's a particular animal, the American lion, Panthera atrox, and it has a really high number of broken teeth. About a third of specimens have broken teeth in Panthera atrox. And yet its microwear looks very cheetah or potentially more tiger-like, right? It's very there's lots of striations. It's not chomping on bone. It's avoiding bone. And so that leads me to conclude that Panthera atrox is breaking its teeth in pursuing those prey, right? It's a solitary hunter, we think, because there are very few specimens of it relative to other taxa or other animals. We think that it's potentially sort of hunting on its own, taking down these prey, and breaking the teeth in the process. But it's not actually munching on the bone, right? It's actually eating primarily the flesh, which we're getting from the microwear. And it's able to eat the prime parts of the carcass because it's taking down that animal. In regards to Smilodon, we do see that Smilodon, also dire wolves, are a bit more sort of Catholic in their bone processing. It's kind of all over the place. They're very kind of lion-like in that regard. There's some that avoid bone. There's some that consume bone. Some that are sort of a bit in the middle, very similar to African lion microwear. But we don't see any indication that Smilodon or really any of the animals at Rancho La Brea were hyena-like. Right. There's no evidence that there was anything that was really specialized on munching on bone, or that anything was devouring carcasses in that regard.
Do we have estimates for how hard it could bite?
So there have been estimates, and this was work done by Colin McHenry and Steve Rowe and their group. And they use this technique called finite element analysis. And there's other tools as well. But essentially, they kind of modeled what that bite force would be. And so assuming that you have in their models a 230 kilogram Smilodon, that bite force is going to generate about 1,000 newtons. So what does this mean? Well, it's equivalent to the bite force of about an 80 kilogram jaguar. Or another comparison is it's about a third of the bite force of a 250 kilogram lion. And so it did have a much weaker bite. And this makes a lot of sense. You're going to have to open that mouth really wide to be able to even get the clearance. And then you're going to have a weaker bite. And so the benefit, again, is really making sure you can deliver that bite to a location on the prey that's going to cause them to bleed out quickly. But you do have to be very careful that you don't break those sabers.
So we've mentioned some of the other competitors for Smilodon around at the time, other felids, also the dire wolf. How big of an overlap were there in their dietary ecologies, or did each one have their own very specific niche? Were they each doing their own different thing?
So that's a great question. So far, we've been able to study saber-toothed cats, American lions, cougars, which are all cats. And then we also can look at things like the dire wolves and the coyotes. And what we find is that overall, on a very sort of large scale, typically the canids, the dogs, are eating things from more open ecosystems. And most of the felids are eating things from more closed ecosystems, most of these cats. Now, that being said, the cats are kind of also doing something different in regards to hunting and or carcass utilization. So as I mentioned, the American lion is sort of likely taking down prey on its own, solitary hunter. It's really eating just the flesh. Smilodon is much more sort of lion-like, potentially hunting in groups and also, eating different parts of the carcass. And then we've got cougars. And so cougars are really interesting because cougars survive the megafaunal extinction. And cougars are interesting because they are highly opportunistic. We know that today. They will alter their diet and what they eat based on what other competitors are around. So cougars will change what they eat when they're present with jaguars. They will also change what they eat when they're present with wolves. And so depending on what other predators are around in these different ecosystems, they will, they're very opportunistic and will eat slightly different prey in these different environments. And so that really makes them well suited to being able to adapt to various changes. One thing that's pretty remarkable, and I don't know if we're going to talk about this later, but is that the cougars survived this extinction. But the cougars were one of the smallest cats in this environment. And so while we think of them as apex predators today, they were actually, one of the smallest cats around at the time of La Brea when you compare them to saber-toothed cats and American lions. And so it's really quite interesting to be able to look at sort of not just the ecology of what American lions and saber-toothed cats did, but also how cougars managed to kind of fit into this ecosystem and how they managed to actually survive with the extinction of a lot of the large megafauna or large animals.
How closely are they all related to each other? What's Smilodon closest related to? And what would be the closest of all the La Brea felids to the domestic cats, which we had a question from Britt Howe and her cats Jazz, Sumi, and Sweden.
Yeah, so domestic cats are Felis catus, and they are within the group Felis. So there's lots of examples of different types of Felis cats or cats that are within the same genus as domestic cats. Includes things like the African wildcat, the black-footed cat, the jungle cat, the European wildcat. So these are all most similar to domestic cats. Domestic cats are quite a bit distinct, but just as distinct, essentially, as lions and tigers, etc., from saber-toothed cats. So saber-toothed cats, including Smilodon and also Homotherium, are closely related to one another. And those make two sort of different types of saber-toothed cats. We have the dirt-toothed saber-toothed cats, which are groups like Smilodon, the very elongated teeth, and then we have the scimitar saber-toothed cats, which are more conical teeth like Homotherium, but also elongated. They are all more closely related to each other than any of them are to extant living cats. And they kind of fall, they're more closely related to extant cats than they are to, say, feliforms, so things like hyenas. And so they are sort of nested within cats, but they're not nested within modern cats or crown group cats.
So when did it all go wrong for Smilodon? Why don't we have it around today?
That's an excellent question, and we've really been trying to answer this. It is challenging to do so. But essentially what we think may have been going on is essentially being a large cat, you need certain resources. And at this time, you have large cats, you have dire wolves, you have American lions, you have giant short-faced bears, you've got all sorts of, predators on this landscape that are eating large animals, megafauna, whether that's tapirs or deer or horses or bison or camels. There's a lot to sort of go around. But what we do know is that the megafauna go extinct. So a lot of these herbivores go extinct, and we see that carnivores go extinct as well. And so it's really challenging to get at the cause and effect. And what some of the potential causes include are humans hunting the megafauna, potentially the bison and the horses and the camels and the mastodons and mammoths, et cetera. Also climate change. And the reason why it's difficult to disentangle these is because people are arriving at a similar time in which the climate is also changing. And so as populations of humans are increasing and hunting activity is increasing, the climate is also changing. And so it's hard to disentangle those factors. But what we do know is that the biggest things went extinct. And the biggest carnivores went extinct as well. The things that survived were able to kind of adapt and eat smaller things. So I always like to joke that I'd love to see Smilodon hunt a rabbit. Probably not really very effectively, right? But, Cougars can eat rabbits, they can hunt deer. They're able to take smaller prey. And so the things that we see that survived were things like the cougar, were also things like the coyote and wolves that are able to eat smaller things and also be highly opportunistic. What's also really interesting is that coyotes actually kind of shifted their diet with the extinction. And so they were eating quite a bit of flesh. And it wasn't until kind of the present day that they really started scavenging and eating, a lot more different types of food. And so we also see that, potentially the extinction of these herbivores and also these carnivores might have also affected what coyotes are essentially doing and altered kind of the dietary behavior of some of the predators. But what we've learned is that it's the opportunists, whether it was things that became opportunistic like coyotes or things that stayed opportunistic like cougars. And cougars, like I mentioned, can eat, armadillos. They've been known to eat alligators. In Florida, they can consume anything from vicuñas and guanacos in South America to elk and deer in North America, and they will vary those types depending on the predators. So they really are very opportunistic and highly adaptable. And so I'm not surprised that cougars are one of the ones that actually sort of survived. But, one important piece of this is, saber-toothed cats, we can easily see how they're hyper sort of specialized with these elongated canines, but also just being bigger. So being bigger in general is a form of specialization in carnivores. And so the bigger you are, the more resources you require, and the more vulnerable you will be if those large prey then go extinct. So one really important thing to point out about extinctions is that it may not be all one cause across the globe. We find that, megafaunal extinctions are happening throughout the globe during the late Pleistocene. The timing varies quite a bit. We're seeing that they're happening closer to, say, 35,000 years ago in places like Australia, closer to 10,000 years ago in North America, and can also vary in Europe and Asia as well. And I think it's really important that we actually study extinctions on a continental and also regional scale, and that we're not trying to look at it all together. This is because, large animals are vulnerable to so many things. We know that they're vulnerable to climate change. We know that they're vulnerable to human hunting. But the causes might be quite different. So I've been studying megafaunal extinctions in Australia, and there it's getting extremely arid. Humans are likely not having a large impact on some of these animals, but the changes in climate might be. In North America, we actually have evidence of human hunting, but we also have climate change that's happening. And so there's a lot of things that we have to disentangle. In Europe, many people think that it was sort of climate change, but also humans had sort of interfered with sort of the routes that these animals could move in that also played a role. And so it may not be the same exact cause or the same percentages of cause all in each location across the globe. In fact, many times we're going to see a synergistic interaction between humans and climate change, but the contributions might be very different in places like North America and Europe and Australia, for example. So I think it's really important that we are careful when we interpret these extinctions. And the other thing I want to mention is, often students will ask me, well, why does it matter? Why does it matter if it was humans or climate change? And the answer I like to give is this. Today we live in a world where humans and climate change are impacting species. So humans hunting and poaching of large animals, and also climate change affects these large animals. So it's really important that we understand how these synergistic combinations of climate change and human hunting affected these animals in the past so we can best develop strategies for managing them moving forward.
Okay, you answered all of my questions about the extinction in one go, so that saves me a bit of time. So what is still left to be known about the dietary ecology of Smilodon?
Yeah, that's a great question. What I'm excited to learn is I'm excited to get these data back in the next year or so. That's going to pinpoint exactly when Smilodon was around, what its diet was at particular moments in time, and being able to actually track that. So do we actually see any sort of dietary change over time in Smilodon? We could expect that as it gets warmer or cooler during glacial or interglacial periods, that you might expect them to change their diet or the degree to which they utilize carcasses. That could all change over time or not. And so it'll be really interesting to see, how are they able to change their diet, or do they change their diet at all over, periods of climate change? And what was their diet, when humans were on the landscape? Did it change in any particular way once humans were here? We don't think that was the case, but just being able to really pinpoint and sort of track their ecology through time is going to be really exciting.
And can we tie this all together and apply what we know of the extinctions at this time, of what we know about Smilodon and large feliform prey, and apply it to the modern day in terms of conservation, for example?
Yes, absolutely. So there's a lot that we can learn. One thing that I've tried to do is, after kind of trying to wrestle with why did saber-toothed cats and dire wolves go extinct, we actually shifted our focus, and we really sort of shifted to looking at the things that survived to try to better understand why they survived and what are the sort of qualities in these predators that allowed them to survive this big extinction event. And in sort of that investigation, we found that being an opportunistic carnivore was really helpful. But at the same time, we also learned that the diets of the coyotes changed dramatically. Now, why does it matter if the diets of coyotes change dramatically? Well, it matters because when we are actually projecting and making models, often they're called bioclimatic niche models, and we're saying, okay, the climate is going to warm by this amount, and therefore we would expect these animals to move in this area and this animals to move in this area. All of those models are based on an assumption that's called niche conservatism. And what that means is what an animal does today, an animal will do tomorrow. And it's important when you model something, you have to make assumptions, and it's important to make assumptions in this case. But that assumption isn't necessarily going to be true in the case of coyotes. So, we see niche conservatism in cougars. We see that they're opportunistic in the Pleistocene, they're opportunistic today. But we actually see a pretty dramatic change in the niche of coyotes. And so why that matters is we really need to kind of step back and say, okay, with climate change, we might see these changes, but at the same time, some of these animals might respond to the loss of species, to various climatic changes in ways that we can't necessarily predict. And we need to kind of think about that when making conservation plans. The other thing that I think is really important to stress is, we think of Smilodon and dire wolves as these terrifying creatures, and they were. I'm not saying I would like to come across Smilodon if I was an early resident of North America by any means. But that being said, apex predators are so key to the health of an ecosystem. And in places where these predators have gone away, in some cases, other mesopredators are able to kind of fill in. So middle-sized predators, a classic example is a coyote. So I live in Tennessee. We don't have wolves in Tennessee. Coyotes are kind of starting to fill into that niche, right? They're able to take advantage of a deer carcass that is, hit by a car, and they consume that. They're able to sort of, eat a variety of different foods. We think that in places like New York, they might even be kind of filling into that more of that wolf niche. And so, we need to really consider these things, but we also need to really managed to help conserve predators because they are critical to the health of an ecosystem. And, I can't really sort of emphasize this enough. Even in places like, Yellowstone, the introduction of wolves has been critical to, reducing certain herbivore populations, to allowing for more healthy ecosystems overall. And so studying, ancient carnivores, why they may have gone extinct, but also looking at modern carnivores throughout their evolutionary history and understanding, their ability to change or challenges that might impact their ability to adapt is also really critical to know.
And so finally, what would you say to a student who is considering researching dietary ecology?
Oh, I think it's the most exciting subject. Obviously, I've devoted my career to it, but I will say that being able to study fossils, to study living animals, to reconstruct what they were doing, how they were hunting, what they were eating, what kind of landscapes they lived in, and do this on a variety of animals all across the globe has been just absolutely fascinating. It's brought me to every continent except Antarctica, which I'm not quite sure I'm ready to venture to at any point in my future. But it's really allowed me to study a diversity of animals, right? So we can study bovids in South Africa, to marsupials, various kangaroos, to marsupial lions in Australia, to saber-toothed cats in North America. There's an enormous sort of variability that we can study. And by really trying to understand their dietary ecology, we can get an understanding of the paleobiology of these animals and also the ecosystems that they lived in.
Okay, Larisa, well, thank you so much for coming on the show today.
Well, thanks so much for having me. I've really enjoyed it.
Paleocast was brought to you by Dave Marshall and Liz Martin Silverstone, with contributions from Tom Fletcher, Vish Venkat, and Elsa Pancharoli. Music was composed by Patrick Kendall Smith. Paleocast was made possible by funding from the Paleontological Society and the Paleontological Association. But the show now relies on funding from you, the listeners. So, if you've liked this episode, please consider donating, and thanks to everyone that's helped out so far. Please visit paleocast.com for the supplementary material to this episode and for our archive of past programs, and follow us across social media platforms to get all the latest news. Finally, if you enjoy our podcast, then please explore all of our video content on YouTube and follow our other projects, the Virtual Natural History Museum and the Paleocast Gaming Network.